So in this video, I'm going to talk about solving systems of equations and specifically just about the number of possible solutions that you can get when you're solving them. A little refresher, a system of equations is just a set of two or more equations that you must find a solution that works in both equations, okay? And so there's a couple of ways to solve them. I'm going to go more in depth on how to solve them in other videos, so you can look at those. But right now, again, I just want to talk about the possible number of answers that you can get. So there are three possible outcomes. The first is that you can get one solution. Okay, this is most likely going to be what you're looking at. And what happens here is you get a point of intersection, right? So if you think of your systems of equations as a couple of lines that you were graphing, your one solution would be their point of intersection, where they crossed, okay? Then you can also have no solution. All right, and so what this means is that these would lines that would never cross, which means they're parallel, right? So parallel lines. And you can have an infinite number of solutions. And what that means is that these are lines that are one on top of each other. They are pretty much the same line, okay? Lines one on top of each other. Okay. So let's talk about, I'm going to look at, first we'll look at the one solution. Okay, so we'll look at this equation, or this system of equations to start with. I have 5x plus 2y equals 16, and x plus 8y equals 26. Again, there are a couple of ways to solve this. I go more in depth on how to the different ways to solve this in other videos. So right now I'm just going to solve this in one way. So I'm going to solve this. I can look here and I see that my x has a coefficient of 1. So I'm going to use the substitution method. I'm going to solve for x here. So I get that x equals 26 minus 8y. All right, so I'm going to use my other equation that I was given. I'm going to replace this x with this 26 minus 8y. So 5 times 26 minus 8y, y equals 16. I distribute my 5. 5 times 26 is 130. I just use my calculator for that. 5 times 8 is 40y. So I get 130 minus 40y plus 2y equals 16. And I'm just going to simplify. So 130, negative 40y plus 2y is negative 38y equals 16. I subtract 130 on both sides. And I get negative 38y equals negative 114. Like I said, I'm just used my calculator there, so I didn't have to worry about, figuring that out on my own. And then when I divide these, I get that y equals 3. All right. Now I take that information. I still need an x value, right? Like I said, these are a systems of equations. So these are an intersection point right now that I'm looking at. So I get x equals 26 minus 8 times my y, which I determined was 3. So x equals 26 minus 24. 8 times 3 is 24. X equals 2, right? So again, this is my point of intersection. If I was, sorry about that. If I were to graph these two lines, I am not 100% sure what they look like, but I do know that they cross at the point 2, 3. Okay, so whatever they look like, not 100% sure, but I do know that that is their point of intersection. So this is what it looks like when you have one solution to your systems of equations. You found a point that works in both of these equations. Okay, now we'll talk about the next. I'm going to clear the canvas. We're going to talk about the infinite solutions next. Okay, so when we have, oops, I want to go back into black. So an infinite number of solutions. Okay, and like I said, that's going to occur when you have lines that are just one on top of each other. Okay, imagine I drew that exactly on top of the other one and not like I did. But anyway, and so what happens here is that you're going to have the same slope and the same y-intercept. Right? If we were looking at these equations in your point intercept form, right? Which is that y equals mx plus b form. Okay. All right. So let's look at an example of what happens here. So you have 4x minus 2y equals 26. And I'm going to look at negative 7x plus y equals negative, 23. I'm sorry, I think I said 46 and I wrote 26? Maybe I said 26. I meant to write 46. And this equals negative 23. All right. So when we get to so you have an infinite number of solutions. When at the end, after you're solving your systems of equations, you get something like x equals x, or 0 equals 0, negative 23 equals negative 23, 105 equals 105. You get a true statement. Okay, whenever that happens, you have an infinite number of solutions. All right, so let's look at these two. Here I'm going to use the elimination method. Okay, like I said, there's other videos that you can look at to go more in depth about the substitution method, the elimination method. But right now I'm looking at this 14x and this negative 7x. And I can say, okay, I'm just going to multiply this negative 7 by 2. And it's going to give me that 14, which when I add them together, they're going to eliminate. Right? I'm going to get rid of this x variable. Now, I'm going to multiply every term in my equation by 2. I can't just do it to that one. Okay, so I'm going to rewrite my top equation because I like to keep things kind of neat. So, and then I'm going to distribute this 2. So 2 times negative 7x is negative 14x. 2 times plus y is plus 2y. And 2 times negative 23 is negative 46. All right. But right now, I've got almost the exact equation, except they're all the opposite terms of each other, right? So when I add these guys together, what happens? 14x minus 14x is 0. Those eliminate. And negative 2y plus 2y, well, that also eliminates. So on this left-hand side, I have 0. And over on this right-hand side, I have 46 minus 46. And that's 0, right? So I have a true statement. 0 equals 0. So this means that any point that works in one of these equations will work in the other one. Okay, I'm just going to go quickly. I did some work. I used the point 1 and negative 16. Okay, and I'll just show you that it works in both of these. Okay, so 14 plus 32 equals 46. And yes, right? 14 plus 32 is 46 equals 46. So that point works in that first equation. And it's also going to work in my second equation. So I would get negative 7 minus 16, does that equal negative 23? Yes, it does, right? So that point of 1, negative 16 works in both of these equations, and any point that works in either equation will work in the other, right? So another point that works in one equation is 2, negative 9, right? So it's going to work in both equations, right? So negative 7 times 2 plus negative 9 equals negative 23. Negative 14 minus 9 equals negative 23. Yeah, negative 23 equals negative 23. And I can do that also with my first equation, right? So 14 times 2 minus 2 times negative 9 equals 46. Well, 14 times 2 is 28 plus 18. Does that equal 46? Yep, 46 equals 46, right? So, and that's going to be true. That's what you get when you have your infinite number of solutions, is that any point that works in one equation will work in the other one, right? They are essentially the same line. Okay. And again, like I said, you would have, if you put it in that point-intercept form, you would have the same slope and the same y-intercept. Okay, now we're going to talk about that last solution or possibility is when you have no solution. Okay, and so infinite solutions means anything that works in one works in the other. Here, no solution means that nothing's going to be a solution to both of these at the same time. Okay, so what happens here is you get, after you do you're solving your systems of equations, you get something like 3 equals 10 or negative 8 equals 24 or 20, yeah, right? These are not true, right? These are all false statements. So if you do all your work and at the end you get a false statement, well, that means you have no solution, right? Nothing's going to work here. All right, so let's see this one. X plus 2y equals 4, and 3x plus 6y equals 18. Okay. So I'm going to do, again, the elimination method. All right, so I can see here I have x and 3x. If I multiply this top equation by 3, I'll have the same variable. Right? So I'm going to do that to eliminate my x's. So 3 times x is 3x plus 3 times 2y is plus 6y equals 3 times 4 is 12. And I'm going to rewrite my second equation, right? So rewrite this one. So I have 3x plus 6y equals 18. Okay, so here, right, you can already see that my left-hand side of this equation is the same, but on the right-hand side, those are not equal, right? So 3x plus 6y equals 3x plus 6y, but 12 does not equal 18, right? And so if we were to continue by doing this elimination method, right, I would subtract 3x minus 3x is 0, 6y minus 6y, and then I would get 12 minus 18, so I would have 0 equals negative 6. Again, this is just a false statement. So that means nothing's going to work here, okay? And if I was to graph these two, I would get two parallel lines. Now, I'm not 100% sure what they look like, but I know that they would be two parallel lines, okay? And so imagine, again, use your great imagination to say that I drew two perfectly parallel lines, okay? So that's where you have no solution, right? So these are never going to intersect. And so those are your three options. You can have one solution, infinite solutions, or no solutions when you're solving your systems of equations.